I am Nishant Agarwal, CEO and founder at lifeandlimb.ai, which is an assistive technology startup at IIT Kanpur. We are making robotic hands which are attached to the human limb, people who have lost their arm from below the elbow or above the elbow. Let's talk about India and how assistive technology is defined in India. India ranks at number 1 in terms of number of disabled or amputated people, but at 56th when it comes to available medical devices that are pertaining to people with locomotor disabilities and amputation. So what we do is we make use of 3 technologies. First is advanced additive manufacturing or 3D printing. Second is EMG, electromyography. And third is electromechanics or biomechanics. Let's go one by one on that, and then I'll introduce the product and give you a small demo of how the hand works. In 2010, 3D printing became very popular and people talked about it that we can make prosthetics or similar devices very much cheaper, but they were not aware of good printing techniques. Now we have multi-jet fusion, which is advanced industry-grade child parts that can be done from that technique, so we are using that. And in 2030s, maybe invasive surgeries would be quite common, so we can have someone like Elon Musk making companies like Neuralink, where a brain implant can be done through invasive surgery and we can control a robotic hand. But LifeandLimb is somewhere between 2010 and 2030s, where we are using techniques like additive manufacturing to make affordability, customization, and aspirational products. Second thing is EMG. Imagine you're touching your phone screen with a plastic pen, but you're not able to do so because our body has 0.7 milliamperes of current flowing over the surface of the skin. And that current is responsible for devices like pacemaker or your ECG machine that you see in the clinical settings. EMG is a similar technology, which is electromyography. Instead of the cardiac system of the human body, we are focusing on the muscular system. So we take the signals from the residual limb or amputated stump of the person or the patient, and then feed it to the microcontroller inside the prosthetic device. These sensors or myosensors are thinnest sensors that we have developed and we have patented as well. We have around 17 patents around the technology, around EMG sensor, as well as the prosthetics and biomechanics. When it comes to 3D printing, there are 3 factors that are responsible for making these devices sustainable. First is that it should be rigid enough that it can sustain the harsh environment, especially in case of countries like India. Second is it should be light in weight. People don't want to have a prosthetic hand which is lying around and not attached to the human body. We have specifically considered using topology optimization so that we can reduce the weight of the plastic parts and incorporate that in the prosthetic device. Third is people in India inquire about the prosthetic device when they are getting married or they have to attend a social gathering. So cosmesis or something like this, which looks exactly like human fingers, is quite common in India. Although people who are providing these devices are focusing on passive devices, they are not actuated using the brain or the muscle power, but we are one of the companies in India which are doing myoelectric or electromechanical devices. Further going into the product demo, we have 2 versions of the product. One is on my left and one is on my right. So the left one is called BioClasp, which is an affordable range of products, starts at 65,000 rupees and comes with 2 years of warranty. It has an invisible switch that you can press and it will show the battery indication. So you press 3 times, it will enable the sensors that I talked about. So there are a couple of sensors around the prosthetic device, one on the left, one on the right. If you give a whirl of the hand, this will be done using the residual limb muscles of the amputee. But if I show you, it has single degree of motion. So we can control it and we can have multiple grip patterns around it. So we can do multiple activities of daily living. So we can disable the EMG sensor with the press of 3 clicks. So that's product 1. We have 12 versions of the product, and this is the latest one that is still in development. We'll be launching that in December in the coming month. It has individual finger movements and it is completely 3D printed. We can offer 6.5 lakh color options, and this can really assist in rehabilitation of the patients with upper limb amputation. It can be removed from the forearm shell, and the terminal device will be separate. You can have a Type-C charging port. It has a display which shows the battery indication, and there are a lot of features around biomechanics that are included in this device. Usually this device is available at a cost of around 40,000 US dollars when imported from countries in the West, but we are able to make it at a price or MRP of around 5.5 lakhs. We are supported by a lot of government initiatives, including grants and awards. We have been recognized by Cornell University, American Society for Mechanical Engineers, MIT, DSR, DSIR, Department of Defense, DRDO, and many such initiatives in socially relevant domain. We are at a stage where we are able to deploy the product using many of the rehab centers and trauma centers in India, including AIMS, Delhi, and Bhagwan Mahavir Sanstha, which is widely known as Jaipur Foot Foundation. We are fortunate enough that IIT Kanpur's Incubation Center has been giving us technological support. I'm one of the alumnus of the institute, and after a short stint at Bajaj Auto, I realized that biomedical devices can also be made affordable because I was making a Pulsar bike in less than 59 seconds, moving out of the factory line. So thank you so much. I'll be open to questions if there are any, and would be happy to talk about it, the products in detail.